Hey YouTube, this is my 5th video in my module on factoring, in which basically we're going to look at a strategy for factoring a polynomial in general. Okay, so walking up to a polynomial and saying, hey, here's what I should try first, here's what I should try next, and here are the things that I should be looking for. So just really quickly, I want to run you through this list, but basically the first thing I again want to point out is you always look to factor out a greatest common factor before you do anything else. Okay, so step 1, always look for a GCF. Step 2, though, says determine the number of terms in the polynomial and try factoring as follows. So basically, anytime you have two terms, okay, can the binomial be factored using one of the following special forms? When you have two terms, we're going to look for things like differences of two squares or sum or difference of two cubes. That's what we focus on when we talk about two terms. If it's three terms, then what we'll look at are, just general trinomial methods, if it's not already a special factoring pattern. So we have some special, perfect square trinomials that were perfect square binomials first. But if it's not one of those, we could just, try and fail until we get something to work. Or maybe it's not factorable, but try our methods for trinomials. And then last but not least, if there are 4 or more terms, we're going to factor by grouping. Okay, grouping is always considered to be something we associate with 4 terms. Otherwise, number 3 here, it says check to see if any factors with more than one term in the factored polynomial can be factored further. If so, factor completely. So basically, look for a GCF. Does it have 2, 3, or 4 or more terms? We can kind of classify it as any special factoring patterns, and always check to see if you can keep factoring. So we'll look at a few examples here before we tune in this video, starting with this one. It says 2x cubed plus 8x squared plus 8x. Can we factor this? Well, hey, rule number 1 said what? Look for a greatest common factor. So I noticed that everything here has, they're even, at least coefficients are even, so they're one of the factors is 2, and they each have an x. So I'm going to start by saying, well, I'm going to take out a 2, I'm going to take out an x. So everything left on the inside, remember we divide out what we took out front. This is the opposite of distribution. So I'm left with 2 x's here, I'm left with 4 here, and just 1 x. And I say in this last term, divide this by 2, we get a 4. So can I factor this? Well, I suppose I could. I notice that this is a trinomial, and its a value is 1. So we could use general trinomial methods. That works just fine. As a matter of fact, if I said, well, can it be written as a product of 2 binomials? Well, what could I multiply to get x squared? I say, well, x and x. What can we multiply to get a positive 4, keeping in mind that they both have to add up to be a positive in the middle. So if it's positive, they either have to have both negative or both positive, and they better both be positive here. And I notice that this is 2 and 2. As a matter of fact, we could write this as 2x, and this is very common. We say x plus 2 quantity squared. This was a perfect square trinomial right here. As a matter of fact, I can point that out right there. Okay, so if you don't notice it, the trinomial methods otherwise with guess and check still work, but this is completely factored here. Taking a look at this example down here, everything has a 3 as a factor, and each one also has an x. So again, let's take a look at this. We'd say factoring out a 3 and an x. I'm left with just an x squared here. 3 out of this is going to leave us with negative 10 and just x to the first, and then 3 goes into 75 25 times, and it lost its x. So I'm going to point this out on this one actually. I noticed that this is a perfect square and this is a perfect square. And I actually, if I wanted to say, well, x is x squared is a perfect square of x, and 25 is a perfect square of 5. If I took 2 times x times 5, I would get this 10 here in the middle. So without doing our trinomial methods, I can say, well, then I know this is a perfect square trinomial, because if I put an x here and a 5 here and a negative here, this is going to say x squared in the front, 5 times 5 is 25 in the back, and I get 2 times x times negative 5 in the middle here. So that was a lot quicker than going through this right here, which, by the way, wasn't even that long. So now we're going to look at what, some people might consider a little bit more of a complex example, but, what if I'm looking at something like this? Now, I'm looking for a GCF first. And the first thing that might bother a lot of people is just there's an a in here, and then these are x's. I mean, what are you going to do with something like that? Not a whole lot in terms of GCF. Nothing here has a factor with another thing other than 1. So step 1, if there is a common factor, factor it out. If there's not, then it says step 2, determine the number of terms and factor accordingly. So now what I notice is, since this has 4 or more terms, remember we said we're going to try grouping. So if we're going to try grouping, here's what I would suggest. Let's put all of the things that have x's here, and I'm even going to include the constant with that. I'm going to say x squared plus 20x plus 100. We're going to put them next to one another. I'm going to put this negative 36a squared over here. And the thing about it is, if we were to actually group all of these together, I notice that this itself is a trinomial. Not just that, it is a perfect square trinomial, because x squared is a perfect square of x. 100 is a perfect square of 10. And if I took 2 times x times 10, I get this middle term. So when I factor this, really what I get is this. I get x plus 10, x plus 10 minus 36a squared. Really, my intent was to write this as x plus 10 squared minus 36a squared. And, you know, if I said, well, we're done, the thing I want everybody to notice is that this difference, it's a difference of two things here. And it's not just a difference of two things, it's a difference of two things that are being squared. So, sneaky. But what I notice is this. We could rewrite this as a difference of two squares, you know, a conjugate pairs. So we say plus minus. And I'm actually going to spread this out a little bit more. We say plus minus. And you'll see why, because if I said, what do I square to get x plus 10 squared? Well, I squared x plus 10. Let's put that in green. X plus 10 and x plus 10 gives us x plus 10 squared. And what do I square to get 36a squared? Well, I square 6a. So I get 6a and 6a. So as far as factoring this goes, this would be the completely factored expression. But these are the steps we go through in the process of factoring. Cheers.